This conference will now be recorded.
Hey, hi, good morning, all, and welcome back to the session that is Big Data Masters Program. Friends, in the previous session, what we have discussed, we have gone through with the introductory part only. And in the introductory part, what we have seen over there, like what is big data? Let me open a notepad. Then explain what we have covered in our previous session. So that will be a quick recap what we have seen in our previous session. Okay. This is our day one of week one Big Data Masters program and recap to the introductory part session. So over there, what we have seen, what is big data, what is say data, information, big data. Okay, so we have seen these particular components or elements, how what like the data is nothing but the collection of facts and figures. Then if we process data, then it is, you can say, moved into the information stage, and which is having certain meaningful values. Once the data is there in huge volume, velocity and variety, then it is called as big data. Then we were having certain constraint in order to handle big data, and those constraint was like processing and storage. We need to have storage for storing that particular data if the data is huge in size, and until unless we are not processing, so we are not able to get information. Constraints of big data, like storage and processing. So storage and processing was two challenges once we talk about big data. And in order to tackle these particular issues, Google had published certain papers in past in 2003 and 2004, and those papers was giving the solution for these two problems. Those were the white papers not having the solution, but a strategy to deal with this particular problem. Now, the duck cutting was a person who was looking for those particular white papers, and he has developed a solution called Hadoop. So, Hadoop was developed based upon the white papers which was published by Google. Say, based upon, or you can say solution based upon papers, white papers, which was published by Google. Okay, so Google has suggested certain solution, and this strategy and this man duck cutting. Let me mention the name as well. Duck cutting. So duck cutting has developed a solution that is called Hadoop, and which is based upon the strategy which was suggested by Google. And he called it as Hadoop. And Hadoop was having two main components, HDFS and MapReduce. So HDFS, what it was? It was tackling the storage uh, issue, or it is fighting against the storage issue, or it is giving a mechanism in order to store huge amount of data. We are having HDFS, like the data will be stored in terms of blocks, inside the multiple machine instead of one machine, and that is nothing but the distributed computing. So multiple machines will be aligned in order to handle huge amount of the data. Then the second component of Hadoop was MapReduce, and this component is dealing with the processing part, how to process huge amount of data. And once like it is processing the huge amount of data, it is further divided into two part, map and reduce. Okay, map, it is going to map uh, the blocks to the machines. Okay, like these machines are going to process this particular data once the data is distributed among machines. Now once the processing is done, then it is given to the another machine for having the final outcome, and that machine is nothing but the reducer. Okay, I quoted one example in our introductory session. Like if you need to broke 10 sticks, and if you are having 10 persons, then 10 minutes, and one stick is taking 1 minute. So 10 sticks will be, you can say, broken by one person in 10 minutes. But if we are allowing 5 persons to broke those 10 sticks, it can be done in 2 minutes. So that is the same strategy which is utilized by Hadoop. Okay, so MapReduce is the processing framework, and HDFS was the storage framework inside the Hadoop ecosystem. Now, moving further, we have discussed like Hadoop was having certain issues in terms of latency because it is the disk processing system. Hadoop, or you can say challenges with Hadoop. Challenges with Hadoop. So certain stuff was there, say latency, disk processing, and disk processing, and another you can say stuff is multiple tools, public applications for different tasks or with different mechanism. Okay, so over here, uh, what this particular line is saying, say once you are working with the Hadoop ecosystem, you will be having multiple things, say, or multiple components. Say you are having ingestion, you are having analysis, and you are having exploration and all. And over there, we are having different tools. Say inside the ingestion, I have walked you through with this particular presentation. Let me open. So over here you have seen like Hadoop was having multiple components, say this was the ingestion layer, it is having flume and scoop. So once we talk about flume and scoop, so these are the tools which are utilized for the ingestion, and once the ingestion is done with these particular tools, the data will be moved inside the HDFS for the storage purpose. But the main thing that you need to note, please focus over here. Scoop and Flume, both of these tools are having different coding mechanism. Okay, it is referring different coding mechanism. It is following different coding mechanism. Hive is having different coding mechanism. Pig is having different coding mechanism. OG itself is it is having different coding mechanism. So standardization was not there. Standardization, like if you are having the knowledge of one language, uh, and you will be able to code on each and every component. So that was not there in case of Hadoop ecosystem. Like one way of coding was not there. We were having different coding mechanism, and that was the, you can say, major issue. If a person who is working on ingestion, he will be feeling, you can say, awkward once he is working in the workflow system. Once he is working for the workflow, you can say scheduling and all. If we allow a person who is working on ingestion to work onto the data analytics part, data analysis part, so he will feel awkward. So that is a challenge inside the Hadoop ecosystem. And a new component came, that is Spark. So Spark came. We discussed about the Spark as well. So Spark, that is in-memory compute engine. In-memory compute engine. And all of these particular things, whatever we are able to see, these can be done with the help of Spark with one way of coding. That is the beauty of Spark. So Spark was discussed. Now, an important stuff inside this big data journey, friends, like we are going to write down the code. Say we are going to perform three main tasks. We will be say ingesting the data, ingestion, then processing, and then sharing output. These are the, you can say, three, or you can say storage. We mentioned storage. After ingestion, you need to store the data in a particular location. Now, these are the four tasks that you are going to perform in your entire data engineering journey. Mentioned in this way. So, what is being happening nowadays? Like, uh, we need to have these particular tools and technology onto the cloud. Just try to focus over here, friends. Earlier, say I'm having an organization and I want to build an application. So what I will do, I will first try to arrange the machines where I'm going to, you can say, develop the code, where I need to for the, let me write it down. So if I am having an organization, and and I got a deal to build an application. And the application is very simple. Say, I'm taking the example from the telecom domain. Say, KPI monitoring. KPI monitoring is the app that I need to build. And for that, what I need to do, I need to first choose like from where I need to get the data. So we are having different data sources. Data sources. Say source one, data source one. Might be possible. I need to. I'm having multiple data sources. Or in another words, in the term of, you can say, telecom, I can say over here I'm getting the FM data, over here I'm getting the PM data, over here I'm getting the CM data, over here, say, let me mention over here, CM data, FM data, PM data. I'm having the alarms. I'm having the uh, core KPI, core raw data. Okay, such type of data was there that I'm having, and what I need to do, I need to first do the ingestion. So it, I need to utilize a particular tool. So ingestion phase came because this particular data is not there in my system where I need to, you can say, process it. So in order to build an application, I need to get this particular data and put it inside my environment. Say I'm having data storage. Over here, data storage layer is there. And data storage, what does it means? So like if the data is in TBs, terabytes, so the data storage must be huge, or I can say like say I am having a particular cluster. So the cluster is having say 20 nodes, 30 nodes, or machines, you can say. At this point, like try to say uh, we are having say 20 machines where I'm going to put this particular data. So data storage, and over here what I'm having, cluster of 20 machines, of 20 machines. So then it will not come the until unless I'm not you can say you going to ingest this particular data into these 20 machines where the processing will be done. So my work will not start, so I need to do the ingestion, and for this there are different tools inside the market which are utilized for the ingestion part. So say if you need to uh, take CM data, so with the help of ingestion tool, you are going to create certain folders or directories inside the data storage of your 20 node machines, and then you will be able to load it up. So ingestion tools you are using, say we are having different tools of ingestion. Let me take an example. So we are having Scoop. Scoop is one ingestion tool. Data ingestion. Flume is another ingestion tool. Whatever we are able to see over here, these are the data ingestion tool, friends. So we are having different data ingestion tools which I can utilize in order to ingest the data, and the usage of tool will depend upon the type of data. Which type of data I need to ingest from the data source, and in this particular case data source are the telecom service providers. Say from the Airtel I'm getting its FM, CM, PM alarms and core raw data. Okay, so it will be ingested to the data storage. Once the data is there, that is in terms of raw format. Raw data is there. Say probably like some of you are from the RF background. So say we are having PM data. Okay, so over here say we are having one KPI, say DCR is there, drop call rate, and drop call rate over here we are having the row counter. Row counters are there, so we are having certain formula, and based upon that particular formula I will get the KPI. So what is happening, data processing will happen over here. Data processing, and try to understand the pipeline with respect to the data engineering. So data storage, after data storage it will be given to the data processing, and with respect to like the ingestion, for data storage I will be having certain databases, data warehouse, data lakes. These are the terminology. Databases, say we are having SQL and NoSQL databases. Say we are having MySQL, MariaDB. These are the SQL database. Cassandra, MongoDB. Okay, HBase. These are the NoSQL databases. We are having multiple databases, my friends, for storing the data that we have ingested from these particular data source. Now moving further, and like we are having different applications of databases, data warehouse and data lake based upon the uses, based upon our project use case, we need to choose database, data warehouse or data lake. Database, data warehouse, like it might be possible in your in some of the projects database is mandatory in order to store the schema, and among data warehouse and data lake we need to opt one. So based upon the project use case, these particular component will be chosen and then moved further. Now you are having raw data inside data warehouse or data lake, then it came to the data processing. So processing will be done and you will be able to get the KPIs. So that is nothing but But the last topic, say of our or last component of our data pipeline, ingestion you have done, storage you have done, processing you have done. Now you are having the KPI, and you will be able to share it in terms of reports, charts, dashboards, or certain files, whatever. Okay, and that will be given to analysis team for further analytics on the top of that data. Analytics. So far, like the designation, those persons are having the designation of say RF engineer or planner, whatever. So you are on to this particular step. You are utilizing the data which is coming from this particular data pipeline. And what you need to learn at this particular moment, you need to learn how you will be able to get this data. Okay, what is the data source, which one is the tool that is utilized for the ingestion, what is the database that is used in order to store it inside the cluster. Okay, and what are the different tools for processing, say, let me mention for the data processing. It is data processing. Say we are having MapReduce, we are having Spark. Okay, we are having inside the Spark we are having Spark batch processing, Spark streaming. Okay, we are having Flink as well, which is like famous inside the market. So we can use different components in order to process the data which we got from the data storage, and that is nothing but a complete end-to-end data pipeline. How a data pipeline is configured and how I will be able to get the outcome. Now focus what I was trying to build. I was trying to build KPI monitoring system. So what I have done over here, being a data architect, so what I need to choose, I need to choose like what are the different file source, what are the different, you can say, ingestion tool that I can use, or which one is more suitable for this particular use case, then database and all, and the data processing mechanism for the visualization, what is the thing that I need to utilize, it might be it is configured with the Power BI. Okay, so Power BI consume these particular reports directly and you will be able to get KPI monitoring. But the main thing why I have discussed about this particular use case, my friends, where I need to have these particular machines. Okay, where I need to have these machines. Now, the thing that will come in your mind, say 20 machine, that is fine. I can purchase 20 machines. I can put these 20 machines inside my data center and then start functionality. Okay, and start functionality and develop this particular application. But for 20 machines, if you are going to purchase 20 machines, so there are certain limitations, you need to have certain upfront cost. So if I'm going to purchase these particular 20 machine and try to build application onto top of that, that will call on premise solution, solution. And for this what I need to have upfront cost, upfront cost. So, upfront cost I need to have, I need to purchase these particular machine, and I need to have some monitoring team and all monitoring, and then you can say certain space and all infra, basically infra cost will be involved. Okay, and uh, security and all these particular things. A lot of, you can say, challenges will be there. Security challenges, challenges. Now, for the on-premise solution, once I'm going to build my own data center, or if I'm having a data center, I'm going to put these particular machine, there are certain limitations. I need to have, say, certain manpower as well, who will be continuously monitoring these particular machines, certain upfront cost, because I need to purchase. If I'm going to take these 20 machine on rent, then as well I need to pay huge amount. Now, as the challenges were there inside the on-premise solution, and another thing, like with respect to the you can say on-premise solution, say these are say natural disaster. If I have set up the data center in Mumbai, and say because of flood the data center is vanished, so the entire data will be lost, and the application will not work. So on-premise solution is having direct impact onto the natural disaster. So what will be the solution if you are not going to opt the on-premise solution? Then what we are having? We are having cloud, friends. Cloud. So we are having different clouds inside the market, or you can say cloud native solution. Okay, and whatever the drawback which we were having inside the on-premise solution, those will be taken care by cloud. Why why I have covered these particular things? Because we are going to learn big data masters program, and it is cloud focused. Okay, so our program is Big Data Masters program, and it is cloud focused. Although, like, we will be going to cover the basics of all on-premise solutions, but our main focus will be onto the cloud services. We are having different clouds, say AWS, Azure, okay, Google Cloud is there, IBM Cloud is there, okay, Alibaba Cloud is also there. So different cloud providers are there inside the market, but AWS, Azure, Google Cloud, these are the main famous cloud service provider inside the market, and we will majorly focus on to the AWS and Azure. Okay, so that's why, like, we are having this particular course module, and if you are able to see whatever I have discussed so far, that is in reference to our course module. So we are having the first topic in our course module, that is introduction to big data and HDFS concept. So we will be going to, we have already discussed about the big data, and like how Hadoop is going to process big data and all, what are the different commands inside the Hadoop ecosystem, we are going to learn in first 2 weeks. Okay, then we are going to start our journey with distributed processing framework PySpark. So what I have told, like, Hadoop was having certain limitations in terms of latency. Then Spark came and it said, like, boss, just give me the storage of your choice, give me the resource manager of your choice, and I will be working in a better way. So we need to opt that component, that is working better than Hadoop, and that is nothing but Spark. Why I have mentioned PySpark over here? Because Spark is providing different API. It can be coded into different languages, say Python, Java, Scala, R. And as the Python is the simplest one, so we are going to cover our module with PySpark. That is demanded in the market as well. That is not, you can say, like, say we are going towards the easy one, but it is demanded in the market. So we are going to cover the thing with PySpark. So up to like first and second module that will be onto your machines, you will be going to configure Spark and Hadoop cluster on your machines, whatever you are having, and then you will move further towards our journey with cloud. So Databricks, Data Factory, these particular things will be covered onto the clouds. Azure cloud, basically, if you are able to see Azure Data Factory, Azure Databricks, these particular things will be covered onto the cloud. And that's why I have mentioned the reference of cloud over here. If you are able to correlate with respect to this particular application, say this application need to be deployed somewhere. Either you are going to deploy it onto on premise, or you can go onto the cloud. Which cloud? You can choose anyone. So nowadays organizations are moving towards the cloud, because cloud are having uh, a lot of advantages. The very famous is a natural disaster. Cloud service provider are having different data zones or data centers into different locations, and availability zone, you can say availability zone and data zones basically. So let me show you one example. Amazon data availability zone. Okay, so it is having, if we call about the AWS, so it is having 31 launched regions and 99 availability zones and 450 plus points of presence. So just have a look. So over here, say inside, like in India, we are having availability zone in Hyderabad and availability zone in Mumbai as well. So two availability zones are there. If like we are going to store say data inside the AWS, so previously let me move this particular example. Say we have deployed our application in Mumbai on on-premise solution, and due to the natural disaster, it was vanished. We are not able to. All the machines were, can say, uh, gone into the faulty state because of the flood, and you are not having the access to that particular cluster. So efforts will be lost. Now you are having, you are, you can say, having solution deployed onto the cloud, AWS cloud. So over here we are having uh, the benefit of these availability zone. If you are having, if you are going to configure or deploy your application in Mumbai, you will be able, you can prefer like the deployment inside the Hyderabad as well. You can deploy it inside the US, UK, or whatever you want, wherever you want. So if we are having natural disaster inside the Mumbai, then the application will be working fine because it's deployed onto the different location as well. You can take it in this way. You are having another copy which is, you can say, onto the another location. So you will be having the benefit. Huh? So that's why we need to move, we need to learn the clouds as well. And this particular program is designed in such a way so that you will be having entire knowledge or a good knowledge about the clouds with respect to our data engineering domain. Now. So data bricks will be covered, data factory will be covered. We will be learning the Spark streaming as well. So up to so far, whatever like we with respect to these topics, so it will be batch processing. With respect to Spark streaming, we will be going to learn about the streaming data. Okay, say a particular source is generating data continuously. We will be going to capture that particular data, and we will be going to process that particular data and sharing the outcome. That we will be learning at the Spark streaming. And over here, Apache Kafka. So in order to, you can say, handle streaming data applications, we need to have certain queue mechanism. So Apache Kafka, we will be going through with Apache Kafka as well. Then I told you like the interview readiness will be there. Say once you have gone through with these particular topics, so we will be going through certain mock sessions and mock interviews basically, and where you will be able to discuss about how you are behaving during the interview, and like what are the different things that you need to do in order to improve your availability during the interview. So those particular things, interview readiness thing. And for this particular module, we will be going to cover certain sessions onto Python, SQL, and we will be covering the rest of the services. Over here two services are mentioned, say Databricks and Data Factory, but inside the AWS we are having multiple services. Say EC2 is there, EMR is there, Athena is there, Glue is there, Redshift is there. So those particular services from the AWS side will be covered, and in the same manner we will be covering the those particular services from the Azure side. So this particular course module is designed in such a way so that you will be having entire, you can say, knowledge. You will be having the complete knowledge starting from uh, the the on-premise system, starting from the like what was the first tool in order to process the data, then certain limitations was there, then we moved to the another tool, then the cloud and all. So you will get each and everything that is required in order to change your domain, in order to get the job. So that is the stuff like what I want to explain. Now the agenda for our week 1, it will be HDFS architecture. We will be going in detail. Oh, sorry, Hadoop architecture. It is Hadoop architecture, not the HDFS architecture. No? So we will be going through with Hadoop architecture. Then how you will be able to install Hadoop in your machines. So certain guidelines are there. You need to just go through with the guidelines, and you will be able to have Hadoop ecosystem on your machine. Then tomorrow we will be going to cover the Linux and HDFS command, and we will be taking the queries, and then after like each and every session we will be going through with certain takeaways. So let me take a pause over here. If you are having any doubts so far, you can ask, or we will move with our normal flow. Naresh, Robin, Akhil, Raj, Kishan, anyone
No,
having
sir.
any doubt?
No, sir. No any doubts.
Okay. Others, Akhil, Kishan, Robin, Raj, fine so far?
Yes, sir.
Yes, yes, sir, it's
Perfect.
fine.
Yes, yes, sir. Yes, sir.
Great, guys. Please try to be interactive during the session. It is motivating, huh? It will motivate me like you are listening to me. Huh? Okay, jokes apart. Huh? So let me try to start the day of our week one, day one, week one. So we will be discussing about the Hadoop architecture and installation guidelines. These are the two topics that I'm going to cover. Let me copy it from here and paste it inside our notebook. Huh? Okay, day one of week one. So if you are having, with the help of, you can say, these particular diagrams, you will be able to understand it a good way. So let me first explain. So we know Hadoop is master and slave architecture, huh? Hadoop is master and slave architecture. Slave architecture. Architecture over here we are having master and slave machines, huh? So slave 1, slave 2, slave 2, slave 3, slave 4. So master machine, in terms of Hadoop terminology, it is called name node. Name node. And the slave machines, these machines are called data node. Data node. And let me mention it DN2. Data node 2. DN3, DN4. Okay. So master and slave architecture, we are having name node and we are having data nodes as well. Data nodes, these are the actual worker. So like master is a person who is not doing anything but instructing to the slave, and slave are working. So in the same way, in the same fashion, inside the Hadoop ecosystem, name node is just instructing these particular slave machine, and these slave machines are working. Okay, and we will be able to get the outcome. Storage and processing is happening inside the data nodes only. Storage, try to focus over here, try to focus on this particular line. Processing and the data storage is being done inside the data nodes only. This particular machine, name node, is going to handle the metadata only. Okay, it is having, in the in another words, the master is having just the instructions like this: need to do this particular task, this particular slave need to do this particular task. So master is having just the instruction. In the same fashion, name node is having the metadata only, and data nodes are functioning. Let me walk you through with a particular problem that we are having in the real world. Say we are having one node cluster, and this particular one node cluster, sorry, we are having four node cluster, and the four node cluster will be utilized in order to store and process our data. Now we are having a particular file, 510 MB file was there, and the cluster is four node cluster. Now, and over here try to be interactive. Okay, so if I'm going to put this particular 510 MB of the data inside node 1, will it make any sense? Friends, the main issue with monolithic processing only single machine was utilized in order to process the data and in order to store the data. Now, if I'm going to use one node in order to store and process 510 MB of the data, will it make any sense to the cluster? Raj Babu, Akhil, Naresh,
No, sir. Sorry, sir. Actually, it's to be distributed in all nodes.
perfect. It must be distributed in all of the machine. So what I have done, I have divided this particular data into four blocks. Some block one, block two, block three, block four. And at this point, like over here, it is of say 128 MB. Yeah? Each block is of 128 MB. And please note it inside the Hadoop 2 or inside the Hadoop version 2 and above, we are having block size 128 MB. And earlier we were having the block size of inside the Hadoop one, we were having the block size of 64 MB. Now, this particular data has been divided into four blocks. Now, these particular blocks will be moved to the machines. Say B1 is onto the node 1, B1, B2 is onto the node 2, B3 is on node 3, and B4 on node 4. That is perfectly fine. Like we are able to move all of the blocks into four machines, and these machines will be utilized to process our data, right?
Yes.
Yes, sir.
Okay. Okay. Now this
Yes,
is
sir.
the thing I have. Yeah. So once you are speaking, then unmute yourself. Otherwise, please go on mute. Like certain disturbance is coming from
Okay.
someone's
Okay.
side. Okay. So once you are speaking, then please go unmute yourself. Otherwise, please be on mute. Okay. So the Hadoop one was having 64 MB of the block size. That is the older version, and Hadoop 2 and above is having 120 of the 128 MB of the block size. Okay. Now that is perfectly fine. I have discussed it like 510 MB of the data was there, and we have divided into the four blocks, and each and every node is having one block, and we will be able to process it. But but who is having the information that where the block 1 is stored, where the block 2 is stored, where the block 3 is stored? Who is having that information? If a client came, I need to get the data outcome with respect to the block 1. So master node, to whom he is going to contact? So he is going to maintain the metadata. Say file 1, the say file 1 is having file 1 block 1 is given to the data node 1, file 1 block 2 is given to the data node 2, file 3 block 3 is given to the data node 3, and file 1 block 4 is given to the data node 4. And that is nothing the metadata, friends. Data about data. Okay, data about data called metadata. So this particular person, the need of this particular person's came into the picture because someone need to maintain wherever where we are having the exact data. If a client is coming in order to process something, then we need to contact to a machine which is having that particular data. Otherwise it is not making any sense. If you have done the distribution and all, and you are not able to get the information where you have stored the data, then the useless stuff. So you must have the information where you have stored the data. So this master node is going to maintain the metadata. And over here, like the stuff what I have discussed, say client came, it has requested, say hey master node, I want to process the file 1, and please get it processed for me. So he will then align the machines, and the machines will be working. Say data node 1 will be working on block 1, data node 2 will be working on to the block 2. Okay, so these particular machine will work, and once like it is requesting, then metadata will be given to this particular machine, and then like you will be able to uh, these particular machines will be working, and then the client will be able to get the information. Over here the client wants to get the information about the data. He want to just fetch the data, he is not willing to process it, huh? So instruction will be given from the master node to process the data, and once the processing is done, the outcome will be shared directly to the client. Now the client is able to get the information. Now another concept came, that is nothing but the replication factor. Master was maintaining the metadata, that is fine, but if a particular node is down, if a particular node is down, our data was divided into the 4 blocks, and if a particular machine is down, say you are having 20 node cluster on premise, and it might be due to any reason, say OS has been corrupted, or certain hardware issue was there inside this particular machine, so it is not starting, it is not behaving properly, and but the data was there onto this particular machine. So what I need to do? So inside the Hadoop ecosystem, my friends, there is a concept of replication. Replication is nothing but maintaining the copies of same record. Okay, and default replication factor inside the Hadoop is 3. So say if we are having block 1, so its replicas will be there. B1, 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 B2, 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 B3, 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 and B4, B4, B4. So I have done the replication and I have stored the blocks in this particular way. Can you tell me, is this particular approach is having any issue? All of you try to look onto the diagram. I have utilized the replication factor 3, and I am having the blocks onto the machines. But is this particular approach having any issue?
Sir,
Yes, I think this is
it,
heavy.
Yeah, yeah. Please go on. One by
So
one you
actually,
can
if
explain.
if the data node one will be shut down, then all the B1 replication will be vanished. I think so.
Yeah, perfectly fine.
yes,
So,
sir, yes, same.
yeah, this is not the correct approach. Although, like we are having the replicas of data, but it is not placed in a good way. What will be the correct way? So, this is the correct way. Okay. Now, like file 1 is given to the file 1 is having say block 1, it is given to data node 1, and block 1 is also given to data node 3, and block 1 is also given to data node 4. Okay, so b1 is here, b1 is here, and b1 is here. Then we are having block 2, it is inside the data node 2, data node 1, data node 2, data node 3 as well, then block 4 onto the data node 1, data node 4, and data node 2 and data node 4. In this particular approach, like replicas are there, but these replicas has been distributed among the cluster in a correct way, in a right way. Okay, now try to think, if this particular machine is down and this particular machine is having information of block 1, block 2, and block 4. So from where I will get? This master is having the information, and how it will be able to know? Based upon the metadata which is placed inside the master name node. So master node is, if say data node 1 is down, so what it will do? It will try to check, say data node 2 is having B2. Okay, that is perfectly fine. We are able to get B2. And then B1, from where I need to get B1? So B1 will be, you can say, get from the data node 3. So B1 will be available. Then B4, it is also available into data node 2. So each and every block will be available if a particular data node is down. Okay, so we are able to tackle the situation, and what we have learned over here. Say if a data node is down inside the Hadoop ecosystem, the master node still having the information about the data, or still maintain the situation, he will be able to get the data with respect to the replicas. Okay, with the help of replication factor, we will be able to recover the data. So data availability is high. Data availability is high. So what is the meaning of data availability? Like if you want to have certain data and it is available, so that is nothing but data availability. And if you are able to get it, so like say, you can say, on the phone call what we are saying, say hello. So from the another side, from the another person side, we are getting the response hello. Okay, that is fine. This is say 100% we are able to get the response. And on the another side, say if we are keep on saying hello hello hello, and from the another person side is not responding, so is not available, we are not able to get the response. So availability is zero at that time. So over here, this is highly available system, highly available system. So we are able to get the data, but how it is possible, how the master name is, no, master node is able to get that this particular machine is live or not, this particular machine is available inside the cluster. So how this master key node is able to get information? Because of the heartbeat message. Each and every machine is sending heartbeat messages, okay, to the master node at every 10 second. Every 10 second, it is going to send the heartbeat, every 3 seconds, sorry. Every 3 seconds, data node is going to send the heartbeat message to the master node. And for the 30 second, over here I have mentioned, like if the name node is not able to get the information consecutive for 10 cycle, so if in 30 second the data node, the master, the name node is not able to get, not able to hear from data node side, then it thinks that this particular machine is not inside the cluster. There is some issue, it is not able to, you can say, communicate, it is not able to establish connection with me. So it treat as a dead node. It treats this particular data node as dead node, which is not sending heartbeat message consecutively for 10 cycles. So that is the beauty. Like this machine is saying, hey, hey master node, I'm live, I'm inside the clusters. In the same fashion, this is also sending the heartbeat message. Hey master node, I'm live inside the cluster. Okay. So every 3 seconds, these particular machines are sending the heartbeat message. Okay, now we are able to get the information. Say this particular machine was not sending the heartbeat message and it is data. Now what this particular master node is going to perform, so it need to maintain the replication factor 3. Okay, over here B1 was having, over here if you are able to see, B1 was having 3 replicas. B1 is over here, B1 is over here, B1 is over here, B2 is over here, B2 is over here, and B2 is over here. So one block is having 3 replicas, and placed into 3 different machine. Now this particular node is down, then in order to maintain the replication factor, the master is going to distribute the load among available machine. So B1 is given to this machine, B4 is given to this machine, and B2 is given to this particular machine. So new copies are created in order to maintain the replication factor equal to 3. Clear, my friends? Any doubt?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Means it's process the same copies to all rest three nodes.
Yeah, it need to maintain the replication factor is equal to 3, and it is being set by you. Okay, Hadoop admin is going to set this replication factor. If it is 2, so then there will not be an issue. Like after the failure of data node, if the Hadoop admin is going to change the replication factor to 2 or to 1, then nothing will happen in that case. It is not going to distribute the load, right? So based upon the replication factor, the things will be maintained in the same fashion. If a node is down, its load will be distributed among the available machine, right?
Sir, please
And
repeat this one again.
so if a particular machine is down, its responsibility will be distributed among the available machine. Okay, so say this machine was utilized in order to store these particular blocks, and we have set the replication factor to 3. So replication factor was not maintained if a machine is down. So Hadoop is going to maintain the replication factor. It is going to replicate the blocks among the available machine, right? And once the replication factor is maintained by creating the new copies in the available nodes, respective, you can say, metadata will be updated inside the master node,
Okay.
right?
Okay, sir.
Try to think in this way, like let me quote an example. Uh, if uh, like if a particular person need to have, you can say, 5 chapatis, okay, and we because of certain, like and two guests are there, and like they need to share the chapatis, but at that moment, like if they need to share the chapatis, what will happen? Or you can say roti, they need to share the roti, yeah? So chapatis and rotis both are the same thing, huh? So what will uh, what need to be done, we need to, you can say, prepare more chapatis. So in this particular case, chapatis are just these particular, you can say, blocks. Okay. And what we need to maintain, we need to maintain the replication factor. If like we are not maintaining the replication factor, uh, if like we are not having, if we are having shortage of the blocks, then the replication factor will be reduced. Just try to focus over here. So if this particular node is down, then the replication factor will be reduced. B1 block will be having 2 replicas only, but we have set replication factor to 3. The person need to have 5 chapatis on daily basis. His hunger for 5 chapatis, but we say if we are providing one, so that is not making any sense. So what we need to do, we need to give more chapatis, either you can say, so over here the copies will be created, so more chapatis will be prepared in order to maintain like 5 chapatis for that person. So in order to maintain the replication factor to 3, we need to create more copies. And over here what I have asked, like say if a particular node is down, then are we going to reduce the replication factor less than 3? No, we are not going to reduce the replication factor less than 3. We are going to create more copies of the blocks. Okay, and let me, you can say, correlate with our example. So we are not going to say like today, as two new guests are there, then you need to take only two chapatis. No, we are going to provide five chapatis to the person by preparing more chapatis. Clear?
Okay, sir. Okay.
Hope
Okay.
the things are
Yes, sir.
clear, right?
Yes,
Are you able to
sir.
correlate? So replication factor will not be reduced. More copies will be created in order to maintain the replication factor to 3. So fault tolerance. Now, the question, previously, once the data node was down, we were able to, you can say, get the data with replication factor. We are able to get the records from the another machines, and that was given by replicas. Replication factor was the parameter, and with the help of that we were maintaining the replicas of blocks into the different machines, and we were able to get it. But what if the master name node is down? If the master machine or master node is down, then what will happen in this particular case? The metadata, where the metadata is stored, master name node is utilized for what, friends?
Name node, sir.
Name node, that is fine, but it is utilized for what?
It is utilized for uh, to take data of all nodes from the in it.
Yes, metadata, that is called metadata. So
Material.
master node is utilized in order to store metadata for all the machines. But if this
Yes, sir.
particular node is gone, then the metadata will be lost, and we will not be having the control onto the cluster. Okay, we are just trying to control our operations with the help of master node. We are contacting to master node, and then it will be having this metadata. Based upon this metadata, it is going to provide the information about, you can say, what is being stored or what is being processed inside the cluster. But if this node is down, then who is going to help? So Hadoop has given a solution for this problem, that is secondary name node. Okay, so we are having another machine that is secondary name node, and we are going to place it with master node. If a node is failing, then it will took the responsibility of master machine, and then from master, you can, from secondary name node, we will be able to take the metadata, and we will be able to process. So over here what I have mentioned, if master node is down, then no metadata and communication to all the machines will be lost. And for this master machine, we are using the high quality hardware, and this is commodity hardware. Like say this is not uh, these machine can have the lower processing capability. It is not, you can say, these are the supercompute type of supercomputers, and they need to have huge RAM or huge processing capability. We can just add our normal laptops inside the Hadoop, or our normal desktop or laptops with the cluster, and it will be start behaving as a part of the cluster. But for the master node, we are using the high quality software, because it need to monitor and schedule the jobs. All the machines will be in control of master node. Master must be brilliant. You know, master must be able to manage all the nodes. So master will have the high quality software. So this is the point of failure inside the Hadoop one, and inside the Hadoop 2 we have done certain changes. So secondary name node came into the picture, and it is going to take the responsibility of master node, and it will be acting as a master node in case of master node failure. Or you can say standby machine is there. Probably you have heard about the standby machine. So these are the standby machines, and how this particular secondary name node is going to handle the situation if the master node is down, with the help of fs image and edit log. These are the two files. With the help of that, this secondary name node is able to took the responsibility of master node, and we will be able to function in case of master node is down. Okay, so just have a look onto this particular diagram. Over here, what we are having a particular, you can say, log file, and it is further divided into the blocks. Okay, say log file text is there, block 5, log file block 3 and 4, log file block 1 and 2. So one log file was there, it is having 5 blocks, and you are having 4 nodes, 1 2 3 and 4 nodes are there, no? So block 1 is over here, block 1 is over here, and block 1 is over here. It's the same thing what we have seen, no? So three replication factor is maintained with respect to all of these 5 blocks into 4 node cluster. Now this, try to focus onto this diagram, friends. So we are having primary name node, or you can say master node, or master name node, both are the same thing. This is the secondary name node. We are having these two machines, and how it is going to update the metadata, how the metadata is maintained. Because this name node is going to store the metadata. Okay, and metadata information, if we are having metadata information, then we will be able to restore our services, or we will be able to keep on functioning with our services, whatever we are doing inside the cluster, that will be keep on going up. But how it can be possible? So inside the primary name node or master node, we are having uh, added log file and fs image. These two files are there, and these two files will be kept inside the shared memory, where, like, this primary node and this secondary name node will be able to update. So fs image and this edit log txt will be captured, and it will be copied inside the secondary name node. Over here the merging will happen in edit log and fs image file, and we will get fs image ckpt checkpointing, and then this ckpt checkpointing file will be moved to the shared memory, and we are having two copies of this fs image ckpt. We are having a copy of fs image ckpt and edit inside the shared memory, and edit log file will be, you can say, given to shared memory directly. It will be going to replace the previous one, and fs image ckpt, it is going to replace the fs image file inside the memory. So it is a little bit complicated stuff, probably you are not able to get. Let me take an example and explain the stuff. Say fs image, like what will happen if a name node is down. Node is down. So what will happen? if a name node is down. So name node is used to maintain metadata. And if it is damaged or lost, then damaged basically, then the metadata will be lost. But Hadoop is having secondary name node to tackle this situation. So what I told, and situation in terms of, okay, take this. Hadoop is having secondary name node to tackle the situation. So name node and secondary name node. SNN, I'm mentioning SNN, secondary name node, secondary name node. So these two persons are there. Now try to think, say, uh, if two persons are working on to the same thing, like if one person is there in your organization and he's working on to a particular project. Now, say if that particular person has put the paper, he has resigned, then what will happen? Who is going to take the responsibility? If like we are not having any another person, what we will do? So a person is working on a project. In case, say, case if he puts the paper, means resign. He has resigned. Now, what will happen in the normal functionality? The manager of this particular person, what will he check? He checks that I need to align the responsibilities what this particular person was performing, and he's going to align another person who is going to take the responsibility of this person, and then normal functionality of the project will go on. That is the one thing. Another case what can be like, if you are the manager is not having another person who can take the responsibility of this particular man who was working on a project, so he's going to have from the outside. Okay, but that will take some time, and it requires certain the transition period, overlapping period must be there, so that this particular person will be able to hand over the activities onto the new person. So this is something like in case of name node and secondary name node. So if the name node is down, it needs to hand over the responsibilities to the secondary name node. And what are the responsibilities? Responsibilities are the metadata. Metadata is the information, main information which this person was you can say performing. Over here, you can say correlate it with this the particular example. Like the person was performing certain activities, and that activities, those particular activities are nothing but metadata in our Hadoop world. Now metadata, and Hadoop has suggested what fs image edit log and fs image, edit log.txt and fs image, fs image. These are the two files which was suggested by Hadoop in order to maintain the normal flow. So what is there inside the edit log.txt and fs image, that we need to understand now. Now, with the help of this particular diagram, probably you are able to understand that yes, edit log txt and fs image is nothing but the metadata, metadata, metadata. This is nothing but metadata, but metadata. So it must be hand over to the secondary name node. Now try to think, if we were having two-person who were working onto the same project, okay, and same responsibilities was given to this particular person, these two-person, then if this particular person is resigning, then I will be, you can say, the manager will say like, hey, like ABC, if XYG has been resigned, or you can say Mohit or Rohit, you can take an example. Say Mohit and Rohit was there. Mohit plus Rohit. These two-person was working onto the same project and having same responsibility. And if Mohit has put the paper, then manager will say, Rohit, just try to you can say manage the activities which was you can say handled by Mohita. So Rohit will be taking care of the responsibility. Over here, in our case, name node is down and secondary name node need to take the responsibility. And what are the responsibility? These are the responsibility. So edit log.txt and fs image, these are the two files. These are nothing but the metadata. And how this metadata is being kept. These are the two different machines. Okay, name node and secondary name node, these are the two different machines. Now, but these machines are sharing a memory, shared memory is there. Okay, whatever the data is coming inside the fs image, that will be, and fs image and edit log, that will be given to the secondary name node as well, that will be copied to the secondary name node as well, and the merging will happen. And once the merging is done, then same will be given to the shared memory, and whatever the there inside the shared memory, that will be replaced with the newer version. But why the merging is being happening over here? Just try to focus over here, my friends. So try to think, say a match is going on. Okay, cricket match is going on, and Virat Kohli, and who is your favorite player? Tell me a name. Okay. Friends, tell me a name. Are you there?
Yes, sir, yes.
Naresh, Robin, Kishan.
Yes, sir.
Tell me a name. Who is your
Ye-
favorite player?
सौरव गांगुली कर दो सर.
Ganguly. Okay. Saurav Ganguly and Virat Kohli. Okay. Both of these persons are onto the crease, and these particular persons are playing. Example to understand. Image and edit flow txt. Okay. So Virat Kohli and Saurav Ganguly was on crease, and Virat Kohli is, you can say, onto the striking side, and once, and he has hit a four, and the score moves to 134 for 2, okay, or 3, whatever, no? So the India's score is 134 to 2. Now this particular record, this is a snapshot, huh? This is on to the scoreboard, and and we can say a snapshot or content of edit log.txt, yeah? So once we have observed the scoreboard at a point of time, okay, at a point of time, the snapshot is nothing but the content of edit log.txt. Now this is there inside the edit log.txt. Now he was striking, Virat Kohli was striking, and he hit 6 plus 6 plus 4, plus 4. So 6, he hit 6, then he hit 4, 6 again, he hit 4. So what will be the total score at this moment? What will be the total score now?
150.
150, yeah? Okay, 150 for 2. So at the snapshot, the score snapshot at a given point of time, that is nothing but the edit log.txt. And after the snapshot, whatever you are getting, that is nothing but the content of, you can say, after snapshot, whatever the update on score, that is nothing but content of fs image. Okay, so that is the content of fs image. 6 plus 4 6 plus 6 plus 4, now the score is moved to 150. You can take it in this way. Once this the content, you can say, was updated inside the edit log.txt, and once this particular file was prepared, then there were certain processes in the background, and those processes has given certain updation to the record, so that, you can say, updation is captured with the help of fs image. Now try to think over here, try to correlate with our example. Now, edit log.txt fs image, these were the two files. This was the snapshot of scoreboard, and this is the updation, like 6 plus 6 plus 4. So that is record is giving to the secondary machine, secondary name node. Now, what will be the final score? If he is going to sum edit log data and fs image data, it will be able to get the final outcome, right? So score will be 150 for 2. So that is the updated one. Now say this will be stored inside the shared memory, okay, and uh, it was having another, you can say, copy inside the shared memory, and the previous one will be replaced with the newer one. Okay, so it is having, the shared memory is having all the updated record. Now once this particular process is going on, okay, it might be possible there is certain, you can say, records, there is another snapshot from the scoreboard that is directly given to the edit log.txt inside the shared memory. Now we are having updated edit log and updated fs image, and that is nothing but the metadata. If this name node is down, primary name node is down, this secondary name node directly contact to the secondary memory or shared memory, basically, not secondary, the shared memory. It will take edit log.txt and fs image and start acting as a primary name node, and our normal functioning will go on. Hope you have understood this particular functionality. If you are having any doubt, you can ask.
Sir, what
Uh,
query is that?
uh,
Okay.
yes, you can ask.
Mhm.
Yes, sir.
Ask one by
Where
one.
is, sir, sorry, where is this, where located this shared memory?
You can give any path, and you can give the path of a machine. You can give the S3 directory. You can give any path. Okay, that will not be say inside the cluster. That will be outside the cluster,
Okay.
right?
Is hi, sir. Is there
Yeah.
any chance to loss of data, like in terms of, as we can say that, in terms of accuracy, in terms of the amount of data, in terms of quality of data, from primary to secondary?
Actually, data is not stored inside neither in primary or nor in secondary. Data is there inside the data nodes. Huh? These machines are utilized in order to store or maintain metadata, data about data. Huh? Metadata is being maintained, and that is of very less size, right?
The same question is for the replication also. As we
No,
know that
we.
there is two or three replicas for each data node,
Mhm.
and so if the data node 1 is failure, so
Mhm.
the other two replicas will be can be stored from the other data nodes with the help of master node. So if the data one is lost, can we say
Mhm.
that other two replicas is exactly with no loss of data and no loss of amount or exact quality of data we can recover from the other
Just
nodes?
just try to focus over here. Okay. So, data node one was lost. Huh? It is not inside the cluster, but we are having replica. It is being created before you can say loading the data. Like once we are loading the data into these particular machine, at that moment we have created the replicas, and replicas will be the same. Let's say B1 will be having the same data. Node 3 B1 will be having same data, and node 4 B1 will be having same data. So these are the replicas which we have created while loading the data inside the cluster. Now this particular node is down. Okay. So replicas are created, another copies are created with the help of the replicas which are placed inside the another machine. Say B1 is inside data node 4 and B1 is inside the data node 3. So one of the replica will be one of the block will be taken into consideration, and we are going to create one more replica or one more copy. So there's no chance of, you can say, data quality issue or data lost, right?
Okay, right.
Is it clear?
Yes, sir.
Yeah.
Okay, perfect. Huh? So now ask with respect to the FS image or edit log.txt. Clear so far?
Yes, sir.
Yeah,
Clear,
it's clear.
clear.
Okay, okay. So things are very simple. Huh? Okay. Now the interesting concept. Huh? So if you are able to see, we are having cluster. Huh? Like say we are having data node, we are having say name node, we are having data node. Huh? And say inside this particular, you can say, Hadoop ecosystem, apart from the data node and name node, we are having certain more components as well. Three more components are there. That is task tracker, job tracker. Okay. So apart from, and secondary name node we have covered. So task tracker and job tracker. These are the two things that we have not covered so far. Let me mention over here. Job tracker task tracker, name node, data node, secondary name node. If you're not speaking, please go on mute. So, friends, please go on mute. Certain disturbance is coming from your side. No, the person. Kishan, no? Let me mute him. No? Okay. So, what I have mentioned, we are having five components inside the, or Hadoop is having five components: name node, data node, secondary name node. We have gone through in detail with respect to these three components. Now, what about the job tracker? It is lying, it is available on master machine and used to schedule and monitor tasks. Then it is available on slave machine and actually performing the task. Okay. So job tracker is nothing. Say if master has a client is coming to the master and he told, like, I want to perform certain operation. So what it will do, it will, you can say, assign the jobs. It will based upon the application, it is going to create the job, and jobs will be given to these particular data node or task trackers basically. So job tracker is going to work in order to schedule the jobs among the data nodes or task trackers. Task trackers are the actual performer. These are going to work as per the instructions given by the master node, and task job tracker, which is going to monitor and schedule the task among task tracker. So monitoring and scheduling the task of job tracker and task tracker, these are the actually performing a particular task and available onto the master machine, slave machine task tracker. Now, in a particular cluster, okay, in a particular cluster, we will be having multiple machines, multiple combination of master node, uh, data node, and multiple, you can say, task trackers will be there. Okay, job tracker will be there, second and name node will be there. So we will be having multiple machines in a particular cluster. And in a data center, just try to have a look. This is the, you can see, picture of a major data center what we are having, and this is the Facebook data center. And on these particular, these are called racks. These particular machines are called racks. These are nothing but racks. And racks, this is the same thing. And racks are having multiple, you can say, machines. So data node 1, data node task tracker, like machine 1, machine 2, machine 3, machine 4, machine 5. In this particular way, the racks or the machines are distributed or configured among the racks. So we will be having multiple machines, and those will be configured inside the racks as per the rack capacity. Okay. And you can think in this particular way. You are having certain clothes and you are having a particular almirah, and you are going to put your clothes inside the almirah. So certain capacity is there. Say your almirah can have 30 pairs of your clothes. So in the same way, we can say a rack is having is able to take, say, 40 nodes, 40 machines can be configured. Those who are from the telecom, they are having the idea, say one BTS is there. Inside the BTS we are going to put hardware, okay, RRUs, or you can say TRXs are being placed, and we are having certain capacity of TRXs which can be configured inside the cabinet. You can think in another way, like say one machine is there, we are having certain capacity of machine, say a machine is of say 64 MB RAM, 64 GB of the RAM. So there must be certain slots of for the RAM, say four slots are there, and you can use for you can have, you can say for uh, you can utilize four slots to put 16 GB RAM in each slot. So in that particular way, like there is certain capacity of rack with respect to the capacity you are going to put the machines. Now this is a cluster basically, yeah. And the machines which we have put, it is not, you can say, it is not like we are limited to single geographical cluster. It might be possible like one cluster can have different machines onto the different locations. Say this particular rack is inside the the London, this particular rack is inside the Delhi, and this is in Mumbai, yeah. Might be possible. And how these particular racks will be able to communicate through the world, like with the help of switches. The interesting concept that you need to understand, my friend, that you are going to create replicas, and you are having a cluster which is having different racks, and you need to create replicas. So where you are going to put your replica, okay. So say this particular machine, let me take an example over here, say rack 1, and say rack 2 and rack 3, okay. We are having, say, I'm taking data node only, data node 1, okay. So we are having these particular data nodes, and for the understanding perspective, I'm going to take name and consecutive order for rack 2, say data node 7, data node 8, data node 9. Very basic concept, guys. Try to utilize your mind, okay, and you will be able to get. There's no rocket science, just you need to focus. You just pay attention over here, and it will, you will be able to digest these particular things. Screen 16, 17, 18. So you are having one cluster that is having say 18 node, and this particular rack is in Delhi, this is in London, or say Mumbai and Hyderabad. Your office, Mumbai and Hyderabad. So three racks are there, and this is your 18 node Hadoop cluster. Now These racks are utilized in order to maintain the replicas. The question was how to maintain the replicas in Hadoop data nodes. Now we know that racks are going to communicate with each other with the help of switches. Okay, racks are going to communicate with the help of switches. You are sitting inside the Delhi location. Now, how you are going to maintain the replication factor 3? 3 replication factor. So 3 replication factor. So you need to store 3 replicas of one block. So how you are going to store? Huh? How you are going to store? Say in this machine, block 1 is given to this machine, is also given to this machine, and also given to this machine. Huh? I am just quoting this particular approach, huh? And you need to tell me what are the issues in this particular approach. Huh? So yes, in this particular cluster, I'm having 3 replicas of block 1, and it is given to node 3, node 9, and node 15. Rack 1, rack 2, and rack 3. And yes, if this rack is down, if certain natural calamities is there onto the very location, then I will be able to recover the data from block 1 which is there inside the rack 2 of data node 9 in Mumbai location. So I will be able to collect the data. But what is the issue in this particular approach? I'm sitting in Delhi. Just try to have a look and tell me what can be the issue in this particular approach. Try to think, guys, and tell me any idea. Let me give you certain hint, like the communication cost. Huh? Once we are
Yes.
communicating, so latency will be there. If we are communicating from the far location, so it will be having huge cost. If we are communicating, communication cost means the latency. Over here, the latency. Yeah. Hmm? Any suggestion? Just try to make a guess. And if you are like suggesting something,
So
then you need to fight against your answer. Huh? Yes, yes, tell me.
we can start from means if the source location is nearby Delhi, so we can
Hmm.
start from Delhi with low latency. Means master
Hmm.
node is in Delhi.
No, no, not the master node. Okay, let me. So, uh, let me try to explain. Okay, first, then you tell me, like if you are having any better suggestion. Huh? So, the issue with this particular approach during the natural calamities, that is fine, nah? But if we are having issue with this particular node only, okay, say if data node 3 is down, then also I need to go to the Mumbai server of rack 2, okay, and I'm going to fetch the data from here. And these are there is a list priority. So what can be the another approach? So with respect to the approach 2, like I'm going to put block 2 over here as well. Block 7 over here, and say block 1 over here, block 1 over here, and block 1 over here. That is fine. Nah? Like if this node is down, then I will be able to get the data from this particular machine. Nah? If the entire rack is down, then I will be able to get from the rack 2 of Mumbai server. Okay, that is the approach too. Approach
Okay,
too.
sir.
Okay, so and third approach, I can have the third approach as well. Huh? Like if I'm going to put all the blocks in a single rack instead of the data node 9 of rack 2, but this is having issue. Like if we are having certain issue with the rack, then the block will be lost, the block v1 information will be lost, and I
Will
will
be
not
lost it,
be
sir.
able to do that. Okay, tell me one thing. If I'm going to use this particular approach, rack 1 and rack 2, and both of these two racks are having issue, then who is going to save us? Who is going to save us?
Sir, there is no
Anybody?
one sir, at that time.
No, no, no. Only God can save us.
Sir, that's I'm saying no one is safe. God to always safe, sir.
Okay. So, so these are the three approaches, and same stuff is mentioned over here, but I tried to explain in a better way. So, same thing I tried to make inside the notepad, but probably you are having the better understanding. Now, what is the approach? You just need to create two replicas in one rack and another replicas into the another rack. So that is the approach that you need to prefer. And another rack means another geographical location rack. Okay, that will not be inside the same, you can say, data center. So that will be the approach that you need to prefer in order to maintain the replicas in case of maintaining the replication factor to 3. Okay, now very interesting concept, checkpointing and forum of general manager. Okay, so high availability, high availability is the thing that is required in our big data world. This is coming at the end. How to achieve high availability in Hadoop ecosystem. And one I have explained, already explained, and you need to tell me how you will be able to achieve high availability in Hadoop ecosystem. What is the technique name? And let me show you the diagram so that you will be able to recall. Tell me the technique name over here, which is utilized in order to have the high availability. Just have a look and tell me. Which one is the technique name?
FS image
That is the file. Okay,
check,
checkpointing.
checkpoint.
checkpointing. So one thing that is there inside the Hadoop ecosystem, checkpointing, and checkpointing, like what we are doing in case of checkpointing, we are merging fs image and edit log.txt, and it is done so that secondary name node will take the responsibility of master node, and he will act as a master. Now one thing that is coming in my mind, basically, say name node, master name node 1 was having some issue, and it is gone in faulty state. Now the second name node has taken the responsibility, but after some time, the primary node, which was acting as a primary node earlier, is came into the working state. What will happen in that particular case? What will happen in that particular case?
Then he is working as a second node name, I think.
Uh-huh. What about others? What about others? Where is our example? Okay. So let's try to answer. Don't think like it is wrong or right. Just try to answer. Akhil, Raj Babu, Kishan, try to be interactive. Robin. So what will happen once the master node came into the live state? The master node, which was working as a master node. So this is the case. Say name node was there, it goes into the faulty state. Then secondary name node, it became the master. Now this is the name node at this particular master name node. And this name node, which was acting as a master node earlier, and if he came to the it came to the live state, then it will not be take the responsibility as a master. Okay, until unless the admin is going to define. Okay, so and it can act as a secondary name node, but the definitions we need to done accordingly. So I think Naresh was saying, so it can act as a secondary name node, but we are not going to disturb master node, which is working as a master at this particular time. Now let me come back onto the slide what we were discussing. So checkpointing, we have gone through in detail with respect to the checkpointing, and checkpointing is the merging of fs image and edit.log.txt, so that like we will be able to get the current information about or current information or current data about metadata, and then it will be placed inside the shared memory. Okay, that is the functionality of checkpointing. Another thing that is being utilized in order to have high availability in the big data world, that is quorum of general manager. Okay, general manager are nothing but the machines, or we can say bunch of machines, that is called that's why it is called quorum, group of general machines. So certain machines are being clubbed together, and these are going to store the information of edit log.txt file. So edit log dot from the active node, like it is being sent the information about edit log.txt, and it will be placed inside this particular cluster. The information about edit log.txt will be placed inside, instead of, you can say, shared memory which was there in checkpointing, it is placed inside the general managers and general nodes basically. That is called quorum of general manager. Now active node is working, and the standby node is able to read the information from general nodes. It is consuming this particular information from the QJM, quorum of general manager. Okay, it is not the secondary name node, but the standby name node. Okay. Now, if this particular active node is down, then over here, like it is logged. Okay, over here, you can say failover controller, it is logged at this moment, and once this particular node is down, then this lock will open, and the standby node will be able to, you can say, communicate to the, you can say, this general node basically JK. Sorry, Zookeeper is the manager over here. So it is able to communicate this Zookeeper, and it will say, hey Zookeeper, now as the active name node is down, I'm going to take the responsibility of the active node, and I will be going to serve the operations which is being happening inside the cluster. So a little bit difference is there, but the zookeeper and general node managers came into the picture. Rest of the functionality will remain same, huh? Okay, the client will be able to communicate to the cluster, and uh, the information will be given by the quorum of general nodes, huh? Quorum of general managers basically. Right, so that is the stuff. Let me mention it over here. Okay, checkpointing and quorum of general manager. Okay, these are the two techniques in order to achieve the high availability, although certain other stuff is also there in order to achieve the high availability. We will be learning in upcoming session, but at this point of time, these two things are more than enough, huh? Just have a look and ask if you are having any doubt, huh? All of you.
Sir, for when active node is down, it is necessary that there is communicated through Juki, or he
Zookeeper
can
is
communicate
the
directly.
controller over here. Zookeeper is the controller over here, huh? It is,
Okay,
or you can say, it is monitoring. Okay, it is monitoring. Is this particular node is up or not? Is this particular node is up or not? Okay, so like heartbeat message kind of stuff is there. Zookeeper is used to have certain heartbeat messages from the node, active node, and until unless it is getting, so it is working this, the active name node will be keep on communicating with the general nodes and all, and the normal functionality will keep on going. But if it is down, it is not able to get the information, the lock will open, and this particular secondary name node will keep on sending the information at that time, then it is reading, still it is reading, so the functioning will go through the standby node, na? Right?
yes, sir. Okay.
Okay.
So it is also working as a functionality checkpointing.
uh, Checkpointing is done or with, or you can say checkpointing whatever the information we are having inside the active node, that is given to these general nodes, general manager, quorum of general manager. In these server, this particular information, that is nothing but the metadata. Okay, so checkpointing
Oh,
related stuff is happening over here, right? These nodes are having updated information, right?
Okay.
Okay, So updated information or live information is being fed to these particular machine, and these machines are responsible for storing the live data from the name node. And once the name node is down, the zookeeper triggers or unlock this particular link. Now standby name node will be able to, you can say, communicate with the client, and he will be, as he is, you can say, reading, he is able to read the data from the quorum of general manager. So he is updated with the information whatever is being, you can say, sent by the active name node. FC is failover controller over here, right?
All right.
Yes.
Okay,
And
perfect.
if Juki is going to be failure,
Zookeeper,
then operation will not happen.
Zookeeper is, you can say, another machine basically, which is controlling. If like that is gone in the faulty state or fail state, then definitely the operation will be impacted, right?
All right.
If
Yes, sir.
controller,
Thank you.
if controller is not there, uh, what I'm able to understand, so if you are able to visualize how we are having, what kind of, you can say, names we are having in the big data world, like Hadoop, we are having the picture of elephant, Hadoop, Spark, we are having deer. Okay, so we are having uh, a hive, we are having, okay, we are having Impala, so let me show you. These all are the, okay, so just I'm just trying to explain, like Hadoop is the picture of elephant, pig, that is the picture of like a pig, that is the analytics tool, we are having hive, this is the data warehouse, and many more are there, okay, okay. So pig, hive, Hadoop, and Spark is there, SQL is there, like fish. Mahout is there, the person who is driving the elephant. So Cassandra is there, OpenAI and all. What I'm trying to say, like, this is a Jew, basically. The tools and technology that we are having, that is a Jew, and Zookeeper is maintained to utilize these particular things. Like if you need to monitor or
Okay.
maintain, so you need to have a zookeeper, we are having different, you can say, animals inside big data world, and zookeeper is a person who is going to
Just see
manage
the
all of these.
all elephant or animals.
Yes, yes, yes. And that is the actual functionality of zookeeper, it is going to maintain,
Yes, sir.
let me try to mention, check, uh, zookeeper overview, so zookeeper is like, the image you can check over here. Zookeeper distributed coordination services and manage large set of hosts. Hosts are nothing but the machines. Applications we are looking for application. So meant for naming services. Why we need to have zookeeper, configuration management, cluster management, leader election, like which one will be the leader of this particular cluster, locking and synchronization mechanism, what we are doing over here in this particular you can say picture, we are locking and synchronizing over here. If this is down, it will be locked and this lock will open. So zookeeper is a person who is maintaining all the resources from the cluster, right? So that is nothing but zookeeper. We will be learning about zookeeper and all, but from the high level, you can what the image I have shown, like big data world tools and technology, like we are in the zoo, and zookeeper is used to maintain these particular tools and technology, right? Try to think in that way. Try to visualize in that way, huh? Right?
Right.
So name are coming in this particular stuff. Huh? Like say Mahot is there. Huh? Mahot image. Huh? Now Mahavat, have you heard about Mahavat? Huh? The person who is driving elephant. Huh? Mahavat.
Yes, sir.
Yes.
So Apache Mahot is a tool. Huh? So it is a framework which is utilized to apply machine learning algorithm onto the data which is stored inside the Hadoop. Okay, so Mahot is there. This is a framework which was built by an IITian from the Kharagpur. Okay, so probably interesting, na? So, the,
Name is interesting, sir.
uh, okay, nobody will explain like me. Okay, so friends, in order to understand this Hadoop is having multiple, you can say, variation or multiple distribution. So what I'm saying, Hadoop is having multiple distribution. It is something like say you are having a refrigerator that can be of Whirlpool, that can be of say Samsung. So in the same way, if you need to learn Hadoop, if you want to learn Hadoop, so it is available into different distribution. Say we are having Cloudera distribution. Then we are having Hortonworks distribution and Mapr. Not MapReduce. These are the three, you can say, most famous distributions about the Hadoop ecosystem, which are providing the Hadoop, and you can download any framework, and you will be able to utilize. You will be able to learn. We are going to pick the freeware of Cloudera, and we are going to install it in our machine, and then we will be going through with the remaining topics of our learning journey. So why we have, you can say, picked Hadoop, Cloudera Quick Start VM. So Cloudera, that is the most famous tool, and it is built by the person who is, who has invented the Hadoop. So we are having simplified configuration over here. We are having all the tools inside the Cloudera Quick Start VM. We are having all the tools which are required in order to have the insight of our learning journey. Say we are having uh, all the tools are integrated over there. Say we are having Scoop, Hive, okay, Spark we can have over there. So all the tools are integrated. We just need to install and start practicing. Management and monitoring, it is also available there. It is like secure, say uh, there are the, you can say, least chances of security breach. It is providing high level of security, scalability and high availability. We know how inside the cloud at a quick start VM, if like you need to have more machines, then you can install, you can add it. It can be horizontally or vertical scalable. We will be discussing in tomorrow's session horizontal scalability and vertical scalability. Sport and community, like it is being utilized by the huge community. So if you stuck somewhere, you are not getting something, then you can ping your questions, you will be able to get the information. So Cloudera distribution we are going to use in order to learn about the Hadoop and how you will be able to get this. So I am going to share this particular presentation and these particular links as well. you need to go onto these particular links, download and install it. Once you have done the once you have downloaded the Cloudera, the virtual box, first you need to download the virtual box, and these are the steps in order to download the virtual box. Okay, for Windows user, and these are the for Mac user. Okay, so once you have downloaded the virtual box and installed the virtual box in your machine, then what you need to do, you need to download Cloudera Quick Start VM. Let me try to show you. So you just need to copy it and paste it over here, say, and it will open the virtualworks official website. If you are using Windows or Mac, you can go with respect to the OS of your machine. And once you click onto the Windows host, so it will ask the path, and you can install it, the path that you want. Once you have done the installation, you just need to move with these particular steps. Okay, so you just need to click next, 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 and you will be able to get VirtualBox installed in your machine. Once you have done the installation of VirtualBox, then you need to copy this particular link, and you need to, you can say, paste it, and then it will ask, this is, you can say, the link of shared drive. So it will, you need to ask permission in order to download. We will approve your permission, and you will be able to download. Once you download, this particular file will be visible in this particular way on your machines. Let me show you. So it will be visible like this, Cloudera Quick Start VM. So it will be visible like this. This is around, say, 6 GB file, what I think. Okay, 5.5 GB. Yeah, it will take huge time in order to download. That's why, like, I have not preferred the installation during the session. But what I suggest, try to download and try to configure your environment today, so that tomorrow we will be going through with the practice of the commands. Okay, and commands like HDFS command and the Linux command. We will be learning Linux as well. So once you have installed the VirtualBox and downloaded this particular Cloudera Quick Start VM in your laptop, then what you need to do, you need to open VirtualBox. Okay, so say VirtualBox is installed in my system. Okay, so VirtualBox is installed in my system. What you need to do, you need to just click onto the import. Okay, at that moment nothing will be visible. Over here we are having three, you can say, uh, images that you are able to see over here. In your case it will be blank, so what you need to do, you need to go onto the import appliances, and you need to give the path where you have downloaded that Cloudera Quick Start VM. So it is available inside Big Data Factory, and say software, and Cloudera Quick Start VM, and you need to just choose this particular file. It will be imported. Once the import is done, okay, then it will ask about the memory, base memory. So at least you need to give 8 GB of RAM. So 8000 you can give 9000 MB of the RAM. Okay, and give one core at least, or two core at the max, in order for your virtual machine. So once you have done, you just need to click next, and you will be able to have Cloudera virtual box in your machine. So you just need to come up with these particular things, and we will move further with respect to like the setup and all. Certain settings you need to change after, you can say, this particular point, and then we will start working with Hadoop and Linux commands. So that's all from my side, my friend. If you are having any doubt, anything in any Anything that you are not able to digest, you can ask. I will be happy to answer. Let me stop recording.